I'm getting the big shaft set up over here on the milling machine because we got to mill the 3 keyways. This is my clamp setup. These are some what I call A blocks just because of A-bomb I made them. There's some, instead of using V blocks, I needed something that would get the shaft down lower in the bed of the mill here in order to have enough room for the quill to do the milling. These are some round pieces that I welded together with some angles attached to it, and I'm using that to hold the shaft. But what I've got to do is shim it, because even though these are all pretty well the same height, whenever I indicate it across here, it's a little bit different. So I'm using some shims over here on the back end, and I'll show you. I got to add another one right now. I'm just running the table down, watching this indicator, and it had quite a bit of taper in it, so shimming up the back to drop this end down, and I'm trying to get it within a few thousandths, and I'm within about 3 right now. I'm going to put one more shim and see if I can get it a little bit closer. I have just different thickness shim stocks there that I cut up. It looks like I hit my mark that time. Not really getting much movement on the needle. Alright, that's going to be pretty good. Now I got to go back in and indicate either one of the sides here to make sure that our shaft is nice and straight and square on the table. So we're reading high as we get further down, so this end is over this way a little bit further, so we just got to do some bumping around, get this thing squared up. Pretty close right there, so I just keep doing that until we get this thing nice and straight. There's a little closer look at the V blocks that I call A blocks. 2 pieces of 5-inch round stock. I forget what size that was in the middle, but it was another piece of chrome bar stock that I welded together, welded the angles on it. I've got it drilled here to accommodate both this milling machine and the boring mill, so I can bolt it over there as well. I've got shim stock here to protect this bearing journal on both sides. We're using brass shim stock just so it doesn't mar the surface. Top clamp as well, we're using a piece of square tubing. I got brass shim stock in between the bearing surface and the clamp bar just to keep from marring it. So we got this thing indicated nice and straight, and it's time to start milling. So I'm using a 1-inch roughing end mill. That's a fine pitch roughing end mill. I've got her offset to one side, about a 1/2 inch, a little less than that. Keyway is 2 inches wide by 3/4 inches deep, so I'm gonna try to rough most of it out and feed it down. 14 inches, we'll move back across and feed it back the other way, and that'll bust out most of the keyway, and we'll have to do finishing after that. Just got some simple plywood guards up here to block the coolant from splashing out. I got a little metal guard down here on the end held on with magnets just to try to contain some of the coolant, because we're on a manual mill, it makes a mess. Okay, we got the keyway roughed out to just under 2 inches wide. We got approximately maybe 50 thousandths or so to come out of it. The depth, we've still got, I'd say, between 10 and 20 thousandths on the depth to clean that up. So we're going to go in with a finishing end mill. Now, this is a 2-flute 1.25 inch end mill, so I'll have to do a step over. And what I have done is I knocked the corners off on the grinder and I honed a radius on there. It's not a very big radius. It's, if I had to, I didn't measure it, but it looks like approximately a 1/16 radius. That's an important feature to have in keyways that take a lot of stress, like a shaft like this. This is a slow speed shaft, but it's under a lot of load, a lot of torque. So that'll help create the corner from allowing the corner to create a crack. I don't know how well you can see it. I'm just trying to get you a shot of it there on video. Alright, so we'll go in there and we'll step it over and get her milled out to 2 inches. I have this indicator set up on a Mighty Mag to keep up with my offset. To me, it's sometimes easier and maybe even more accurate to, if you've got a good dial indicator that's not moving around on the screws, to help keep up with your offsets. And it's also a backup just in case that readout isn't giving you exactly what you want. So we start in the center whenever we center out the shaft, and I'll plunge it in about halfway to 1/2 inch. That's a 1 inch travel. And then when I do my offset, it'll be 0.375. Just using a India stone to lightly deburr that little burr on the top of the keyway. It'll roll it over, so you got to get the inside also. Got a nice looking key in there. Nice radius in the corner. Alright, that end's showing about 4 thousandths under on the depth that I want. And this one is about 6 thousandths, so about 2 thousandths taper in the depth. And I think that has to do with the table moving. As all this weight is shifting to one side of the saddle here, it's drooping and moving on me. So I'm going to take another cut in the bottom there. Let's see what I can get on the sidewall, the width. We're going to use that adjustable parallel there. Make sure it's cleaned off. Alright, so I cut it just slightly over 2 inches by 8/10. So that'll work fine right there. I won't have to worry about cutting the sides again, but I'm going to come in here and scrape the bottom out a little bit. There's a pretty decent 1, 2, 3 block. got this side finished out. Got it to the right depth and the right width. Here's that other 1, 2, 3 block. I've already mic'd it. So we're good on our size. So I've got to clean this up. I got to actually move this thing around and re-indicate it again and get to the middle keyway. All right, getting the shaft re-shimmed here on the V blocks to cut the middle keyway, and I finally got it. I had to remove some shims. Actually, I got one shim on each side, so it's pretty well even now on the blocks. The shims that I have here is to protect the surface. All right, now we'll have to move it off to the side and make sure that it's parallel again to the table. All right, we've been getting the shaft indicated this way. I had to bump it about 5 thousandths and get it in. So I think I had it within about half a thou. That's 1/1000th from there to there. This is my setup for finding the center of the shaft. I'm just using a 1/2 inch edge finder, and I'm using a 1/2 inch end mill holder. I don't have the set screw tight. It's a very snug fit inside that end mill holder. I just use the friction. It goes up into about where the set screw is and it gets snug, so I just push it in there until it stops. Just like so. I've already found the edge. There it is. Measure this diameter, divide it by half, add 0.250 for the half of this diameter here, and that gives us 4.6325. Use the digital readout, move that to the center, and that's the center of our shaft. So we got the shaft centered up. I've got the spindle centered up on the length of the key where I want to go. The blue marks should just kind of identify the center and the end. So I'm plunging. That's a center cutting 1-inch roughing end mill. I'm just going to plunge it a 1/2 inch deep. Now this is a full depth key, which is going to be 1 inch deep here. I'm just going to take a series of cuts to mill it out with this 1-inch roughing end mill. And then like before, I'll go in and I'll finish it with an 1 1/4 end mill. Alright, so that's a 1/2 inch deep. I'll just kind of back off on the table. Get rid of the slinging chips, and we'll start making a cut. So that's feeding about 2 inches a minute. I'm running, that's 180 RPM on the spindle. In Wondering about the mill, it's a 5 horsepower motor, it's a 40 taper spindle. So the first series of passes, I went down a 1/2 inch, 3 passes. I went down the center and then offset it to each side. And then I went back to the middle, plunged another 1/2 inch deep, made a pass, and I just offset it the first time. And we're headed back that way with it. And we'll have to come across and then back down the other side. And then from there, just do some measurements to kind of see about how wide it is, about how deep it is, and maybe make one more pass around it to get it really close before we swap out to our finishing end mill. There you can see it roughed out. I've got it really close. There's a little ridge in the center right there because I'm using a 1 inch end mill with a radius on the corner. This is about 2 inches wide. I'm going to use this adjustable parallel. This is just rough measurements. This isn't finished measurements here. Okay, right on par for what I got measurement. So we've got approximately 50 thousandths to come out the width. I've already just kind of rubbed this with some emery to remove the burr. And I'm going to use a depth mic. Alright, so that's telling me we've got about 25 thousandths on the depth. Actually, it's a little bit more than that, so I'm just going to say about 30 thousandths on the depth there that we'll have to go, and we'll do that with our finishing mill. What I'm doing with the finishing mill before we start milling it out is I'm busting out the 4 corners there, especially on this end since you got such a high wall right there. And this mill will just squeal and squeak and beat and bang. So I'm relieving the corners since that's going to be a wide area of cut. I just did those 2 right there. I'm going to move down and I'm going to cut these 2 corners. Depth, so we're going to go ahead and plunge. Zero it out. Let's get some coolant going. get it. Then I got the top deburred. I use this stone right here and I just lightly rub it and then rub the inside. I already got that done. The keyway looks great. I'm gonna check my depth. I want like 5 thousandths over 1 inch, so 1 inch 0.005 is what I'm kind of hunting for. Six thousandths. All right, so we're +6 on the depth right there. That means we're good. All right, here's the key that goes there. This is the one that come out of the old shaft. I think we got a good fit on that. You out of here? All right, man. See you tomorrow. I think that's going to work pretty good. So we'll move the cutter and we'll test fit it up in there. All right, that's going to work good right there. You'll be able to tap that down in there. I don't want to do it now because I don't want to have to fight it out of there. If you do need to get the key out there, you can usually just take your chisel. This is how I remove this. And get right on a corner somewhere and just hit it with a chisel and a hammer, and it'll usually pop it up and you can get it out of there. Yeah, it's going to be pretty good right there. So I am going to have to dress 2 of these corners on a radius to clear the radius in the bottom of the key. The factory shaft didn't have a radius in this keyway here, so I went ahead and used the same end mill on the other ends. Gives it a little bit extra strength there in the corner from breaking out, but the end of the shaft where the coupling goes is where all the torque goes. That's where the problem is. So we're just about done. I got to do some cleaning up around here and then we'll check it out. We'll go ahead and do a check with the parallel and a micrometer just to kind of verify. Sometimes it's a little tricky to get these things squared up. Looks like I'm about 1 thou under right there. But that's going to be good because we want that key to fit in here kind of snug. So as it's being bumped down in there, if he feels like it's too tight, then all he's got to do is just kind of dress the side of the key a little bit. But whenever this shaft is dropped into the gear, this key is in here, and it's best to be just a little bit tight so that it doesn't fall out, because the shaft is picked up vertically, you know, and you don't want the keyway to fall out as you're dropping it down into a hot shaft, you know, moving. So that's a good fit right there. I'm happy with it. We got this job completed, everybody. This is always a good time to see all your hard work come to an end and have the final product in front of you. And this one turned out good. Everything is on size just the way I want it. All of the diameters, the shoulder lengths, all the keyway widths, the depths are good. Everything's there. I'm happy to see this one done. I've got about a week in this. I just figure a standard 40-hour work week is about what I got in making a project like this. Working on and off, you know, I get pulled off of it because you have to work on other jobs. But this is the kind of stuff that I do really enjoy about my job. I like making these kind of shafts right here, and it's fun. You know, we're using a 1940s lathe, this American pacemaker, and making some nice parts on it. Whenever I'm roughing it in, you'll see these other ones like 8.8. That is a rough dimension that I'll rough it into, and then I'll have like a final dimension wrote on there too. So this was the reason why this one needed a new shaft, is because of the crack right there that established in the key. And this did have a radius in there for all the guys that think that, oh, that keyway needs a radius. They usually do have a radius milled in there, but that is under a lot of stress, a lot of torque, and that's just, sometimes it's inevitable. That's what happens. Now I asked for the application because that's a question that I'm always asked, especially on the Instagram post and the Facebook post. People always want to know what this goes in, what does this do? And many people don't realize, they're not fully aware of all the heavy industry out there in the world. I like to consider it the industry that makes what you buy, you know, the parts that make this world evolve and make this world turn every day. If you think of the simple things every day that you buy in the store, your groceries, a lot of your groceries come in a little cardboard box, right? If you buy cereal, a lot of times it's in a cardboard box. Well, there's paper mills that make that paper, and in those paper mills you have thousands and thousands of pieces of rotating equipment like this: hydraulic cylinders, pneumatic cylinders, gearboxes, just all kind of equipment to create those products that are used to make the products that you buy every day. So as I was saying, for this one here, now what I can tell you is that this is for an OSB plant that makes OSB board, you know, like kind of like plywood. We know that it goes to that, but we don't know what the direct application is. But we do know that that failure is common on this shaft. It must be under an extreme amount of load, because it's always cracks down on that end. So hopefully that'll help you out with your curiosity. It goes to an OSB board, and maybe it's used to help make wood, plywood that you buy. So I hope you enjoyed following along. I enjoyed sharing it with you. And if you like this video, please give me a like, give me a thumbs up, and drop me a comment. Let me know. All right, guys, we'll see you on the next job, okay?